I'm Sabrina Ramonov, and in this video, I'm going to build an AI agent system to help me understand new research papers related to artificial intelligence. I'm going to use a low-code platform called StackAI, which requires no coding at all. And for those of you that don't know me, my background's in computer science and physics from UC Berkeley. Right out of college, I founded an AI startup called Qurious, which specialized in online speech recognition and natural language processing for contact center interactions. I sold the company in 2021, and these days I'm really just playing around with Gen AI with special attention to AI agent systems, and I really love being able to build them without any coding or technical know-how involved. So that's why today I'm going to try using StackAI. It is limited in terms of multi-agent collaboration capabilities, so it doesn't support cycles and graphs for those of you who are more technical. But let's see how far we can get anyway. Here, I've just kind of outlined roughly what it is I'm trying to do. Like I said at the beginning, my goal is to quickly understand new research papers that come out. And what I'm thinking for this agent system is 4 different agents. One to kind of summarize what's the point of the paper, what's interesting about it, what's unclear. A more specialized agent coming from a deep learning background who extracts interesting deep learning methods related to the paper. Another specialized agent who's conditioned on a mathematician context, who figures out what theoretical math concepts are important in the paper and also mentions other theoretical references that could help understand the paper. And then another agent that plays the role of a skeptic to try to find like unjustified assumptions or weaknesses in the paper. These are the 3 agents I'm going to be focusing on today, and then if I have time, I'll get to the summarize agent. All right, I'm going to head over to StackAI. For those of you not familiar with it, this is a low-code agent builder platform. It's really designed for enterprise teams, and it has all kinds of security certifications tailored to the enterprise. You can see no coding required. It has enterprise-grade security with SOC 2, HIPAA, and GDPR. You can deploy it on-prem, all sorts of good stuff. I'm actually just on the free plan, which I will open up here and zoom out. So because I'm on the free plan, I am going to be limited in terms of like what models I can use. For example, I can only use like ChatGPT 3.5, not 4. But in this case, since we're doing research papers, I want to use Perplexity anyway. So I'm just kind of zooming out, trying to get everything. Okay. Okay, so our input here will be the paper that we want it to kind of summarize. This is the paper that I'm going to use for testing. It's a survey paper about planning with LLM agents. Okay, just going back to what we're trying to do, we're trying to create these 3 separate agents. So I'm going to go back to StackAI and then drag 3 of these LLMs together. And yeah, I don't want to use ChatGPT because I feel like ChatGPT 3.5 is just going to suck for this. So I'm just going to use Perplexity, which thankfully I can access on this free plan. Okay, so now we have 3 different Perplexity-based agents. I'm just hooking each one up to the input. Okay. So this one is going to be our, let's say this first one's going to be our deep learning agents. This one will be our mathematician agent, and then this one will be our skeptic. So just starting with a deep learning agent, let's give it like a prompt and identity and all that good stuff. So starting with the identity, you are a professor in deep learning with a PhD. Let's say from Stanford. And then the goal is to extract interesting deep learning methods that are related to the research paper. And then here in StackAI, how the variables work is you just reference it like this. So since we connected this input to this agent over here, the agent can access the variable. Okay, really simple prompt. We just gave it simple context and then a goal to extract interesting deep learning methods, and then we'll see how that does. And for those of you new to agents, you might be wondering, why don't you just give one big prompt to the LLM and have separate steps asking it to extract deep learning methods and then another step to extract math concepts and so forth. And the reason why I decided to separate into agents is because typically I get more sophisticated answers because each agent is conditioned on a different context. So what I mean by that is for this agent, we're telling it it's a professor in deep learning, like that's its background. And then for the next agent, we're going to say, you know, they're a professor expert in theoretical math. So because we're giving each agent like a separate identity, its final answers will be conditioned on a totally different context. You get literally different answers. So for this second one, let's just say you are an expert theoretical math. It's the identity. Your goal is to extract theoretical math concepts that are important to this paper. And then we reference the variable. And then for this, I do want to give it kind of a step-by-step, only because I have played around with like LLMs reading math papers in the past, and it generally does struggle. And so I do want to give it kind of a step-by-step breakdown of what to do to help it out. Okay, so the first step is to read and understand the research paper, and then I want it to think first. So think silently about the most important, say, theoretical math concepts related to the research paper. And then we could say, what are the top 5 theoretical math concepts related to the research paper? Provide, yeah, let's say we want an example from the research paper of how each math concept is being used. Okay, so we'll see how that works. We can change this later. Trying to think anything else. So we have the steps. Yeah, we'll do the chain of thought here. So take a deep breath and take it step by step. And the reason why I have this much longer prompt, like I said before, is having played around with LLMs and math-related tasks, it can struggle and just kind of hallucinate random things or go in a direction I don't want. And so I'm just trying to be more clear about what it is I want it to do and the steps that I want it to take. And then this last agent will be our skeptic agent. So we're going to give it the condition of you are an expert in all of these fields, let's say like artificial intelligence, deep learning, and mathematics. Not super realistic, but let's see what it does. And then you will be given a research paper. Your goal is to find unjustified assumptions in the research paper. I was going to say weaknesses, but I feel like that might be vague. Like what I'm really looking for to quickly understand a paper is like, what is it about? What are the key contributions? What are the deep learning and math concepts related to it? And also what are the weak points in the sense of, they're not backed by data. They're kind of general assumptions that the paper is making without having much evidence to support it. And maybe the paper links to another paper, which is totally fine, but that's kind of what I want to know. I want it to surface, like, what are kind of the weaker assumptions in the research paper. And then I don't want it to ramble, so I just want to say your writing style is Spartan, factual, and scientific. Okay. And then similar to the math professor, I am going to give it some steps as well. Let's see if that helps. So read and understand the research paper. It's the inputs. Think about ideas in the paper that seem unjustified and lack supporting evidence. Yeah, I think that's a good way to say it. Summarize the top 3 ideas in the paper that seem unjustified. That's not to say that it is unjustified. I just want the agent system to surface those potential weaknesses so that I can be aware of it and like take a closer look if I'm interested. And similar to the math professor, we'll add a little chain of thought at the end. So take a deep breath and take it step by step. Okay. So it looks like I jumped forward to building everything because my screen recording app, Screen Studio on Mac, literally failed to save the build out twice. Like literally it just failed to save like the past hour of recording when I did the initial build out, iterated on the prompts, and then I filmed it again and it's failed to save again. um, so I'm going to switch recording apps, obviously, but just for this video, I at least wanted to show the final outcome. So annoying. So yeah, just to recap at a high level what I did, and then I'll dive into the specific examples. I built out a 3-layer agent system for the deep learning agent, a 3-layer system for the theoretical math agent, and then a 2-layer system for the skeptic agent. Why I'm doing that, kind of unrolling the feedback loop, is because the low-code platform itself is pretty limited. I can't build out true multi-agent collaboration and communication with cycles and graphs. So in an ideal world, what I mean by that is it would be great if we had our deep learning PhD and then another deep learning PhD, and they just talked back and forth, iterating on an output until it reaches a certain level of quality based on evaluation metrics or whatever. Can't quite do that here, so what I'm doing is unrolling the interaction. So we have our first deep learning agent produce an initial answer, a second deep learning agent provide feedback on that answer, and then a third deep learning agent incorporates the feedback from the second agent to the answer from the first agent and then produces the final output. Similarly, we would do the same thing for the math agent. So we have a first theoretical math person produce a first pass, a second theoretical math person provide feedback on the first answer, and then a third theoretical math agent combine the feedback with the initial answer to produce a final answer. And again, the purpose of all this is so that we have higher confidence in the final answer, so that, you know, if I'm asking and trying to figure out what are the theoretical math concepts related to the paper, I want higher confidence that the LLM is not just like hallucinating random math concepts that have nothing to do with the paper. And so that's the purpose of this kind of second layer QA agent that looks at the first agent's answer and kind of confirms that it makes sense with respect to the research paper. And then for our skeptic agent, I just built out a 2-layer one. And so this second layer skeptic agent looks at the list of unjustified assumptions produced by the first skeptic agent, checks the research paper's references to see if there is any supporting evidence. And then I also ask this agent to rank the unjustified assumptions based on which ones have the biggest impact on the conclusion of the research paper. And so just diving in real quick, mostly because I'm like really nervous this is gonna fail filming again. Just real quick. So if we look at the output of the math agents, so again, the first layer math agent, we just ask it to extract theoretical math concepts related to the paper. It extracts these 5 just from scanning this, and like from what I know about the paper, which is over here, understanding the planning of LLM agents. I don't think formal language theory is a big part of this paper. And so what we're gonna do is feed this into another agent whose task is to read the paper, review the proposed list of math concepts from the first agent, and then determine which math concepts from that list are not really applicable to the research paper. Then we add a little chain of thought at the end, take a deep breath, and take it step by step. And yeah, as I suspected, the formal language theory that the first agent mentioned is not really relevant to the paper, and the second agent found that out. And by the way, this is a really common design pattern for multi-agent systems, where you have one agent do the initial work, whatever it may be, a first draft, a first analysis, whatever, and then you have a second agent provide feedback and do QA on the output of that first agent. Okay, so this is the kind of feedback, hey, this concept is not applicable. And then we feed that into a third theoretical math agent. And this guy is basically taking the output of the first one, incorporating the feedback from the second agent, and then producing a final output. So this is the final list of theoretical math concepts related to the research paper, and then we also ask it to provide an example of how each math concept is being used in the paper. And you can see here, formal language theory is no longer included in the list. It's been pruned from the list after the second agent's review that it's not really relevant to the research paper. Okay, And so that's basically the step-by-step process. Similarly here, let me go, the skeptic agent was pretty interesting. The deep learning agent already had a pretty good initial output. And so the second agent who reviewed that said all the methods listed are directly related to the paper, which I agree with. I mean, these are all directly related to the survey paper on LLM planning. But the third deep learning agent tasked with incorporating the feedback from the second and combining it with the output from the first, I really liked its final output and the way it formatted it, because it also explained like each of these examples. So the first deep learning agent mentioned things like Hugging GPT, but didn't expand on what that was, whereas this final answer from the third agent expands on the deep learning methods that are relevant to the paper and also expands on each example that was mentioned by the first deep learning agent. So I really like the format of that. And then real quick, going to the skeptic agent. Okay, so the first skeptic agent, we tasked it with finding ideas in the research paper that seem unjustified and lack supporting evidence. It produced this list of 7, which I was pretty surprised. It's a long list. But then we introduce a second skeptic agent whose job is to review this list of proposed unjustified assumptions, check whether there is supporting evidence in the research paper's references at the end. If a topic does have a bunch of references, then we remove it from the list of unjustified assumptions. And then we also ask this agent which unjustified assumptions have the biggest impact on the conclusion of the paper. And so here you can see the output from this second agent. Here are the top ideas that seem unjustified, and then it finds here, let me just zoom in. It finds after reviewing the references in the research paper, I found some of these assumptions are indeed supported by existing works, such as the effectiveness of task decomposition and the role of external planners. Okay, so it removed task decomposition and external planners from the list. That's number 3 and number 5. So you can see in its final list of assumptions that are unjustified, it's down from 7 to 5. Okay. Yeah, so just zooming out here. So again, this is the multi-agent system I've built using a low-code platform called StackAI. Absolutely no coding was involved. I'm on the free plan, so I couldn't use ChatGPT 4. I just used Perplexity for all of the agents for now. And what's really cool is this kind of simulates what a multi-agent interaction / collaboration would look like, where you have, one agent do the initial work, another agent provide review on the work, and in our case, since we've unrolled that feedback chain, we have a third layer of agents for deep learning in math to incorporate the feedback into the initial answer and produce a higher quality final answer. And so this was really cool. I built this all in under an hour. Unfortunately, it didn't save twice. Thanks, Screen Studio. But it was really fun to put together. And you can imagine adding other types of roles to this tree. So for example, you might have an entrepreneur type of agent who's tasked with thinking of business ideas inspired by the research paper. You could have a governance type of perspective that thinks about QA, ethics, guardrails, and that type of thing. And so there's a lot of cool things you can do with agents. And the reason why it's important to separate these tasks to different agents is because it's the LLM's answers are conditioned on totally different contexts. So it's going to produce a totally different context when you give it the identity of a deep learning professor versus giving it the identity of a math professor versus, for example, giving it the identity of like a 6th grade science teacher. Based on that context, the LLM will be conditioned very differently and produce very different answers, which is why I wanted to separate the analysis of the research paper into separate agents, each one with a specific identity and narrow scope. I'm Sabrina Ramonov. I hope you enjoyed this brief video that was supposed to be a long video showing me building this from scratch, but unfortunately 2 of my video recordings didn't save. But yeah, if you enjoy this type of stuff, hit like, hit subscribe, drop a comment. Look forward to hearing from you.